In Lesson 2.8, we're looking at how to prove angle relationships. You'll learn how to write proofs involving supplementary and complementary angles and write proofs involving congruent right angles. How do scissors illustrate supplementary angles? Notice that when a pair of scissors is open, the angle formed by the two blades, angle 1, and the angle formed by the blade and the handle, angle 2, are a linear pair. Likewise, the angle formed by the blade and the handle, angle 2, and the angle of the two handles, angle 3, are also a linear pair. I imagine if we wanted to show angle 1 plus angle 2 equals 180, that's a linear pair, and angle 3 plus angle 2 equals 180 is also a linear pair, we could then show that since they're both equal to 180, angle 1 plus angle 2 must equal angle 3 plus angle 2. And then we could subtract angle 2 from both sides, and we could prove that vertical angles are congruent. Angle 1 is equal in measure to angle 3. Put some measures in there. The postulate number 2.10 is the protractor postulate. Given ray AB and a number r between 0 and 180, there's exactly one ray with endpoint A extending on either side of ray AB such that the measure of the angle formed is r. Yep, we can measure angles just like segments. So you won't be surprised to know that there's also an angle addition postulate, just like there's a segment addition postulate. If r is in the interior of angle PQS, which it is in the picture, then the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. Or reversing it, if we have the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS, then R must be in the interior of angle PQS. The converse is true also. This is a nice little application problem of the angle addition postulate. The diagram shows one square for a particular quilt pattern. If the measure of angle BAC is the same as the measure of angle DAE, and they're both 20, so 20 plus 20, and the measure of angle BAE is a right angle, so plus A that we don't know equals 90 degrees in a right angle. So 40 plus A equals 90. Subtract 40 from both sides, and we have A equals 50. Find the measure of angle CAD. So the measure of angle CAD was 50 degrees. Oops, kind of snuck ahead there and got the complementary angle theorem in there on accident. The supplement theorem says if two angles form a linear pair, they are supplementary, so they add up to 180 degrees. The complement theorem, if the non-common sides of two adjacent angles form a right angle, then the sides are complementary, they add up to 90 degrees. If the measure of angle 1 and angle 2 form a linear pair, and measure of angle 2 is 166 degrees, find the measure of angle 1. Well, we know a linear pair adds up to 180 degrees. So all we need to do is subtract 166 from both sides of the equation, and we get 1 is 14 degrees. They're still building our list. So for angles, yes, reflexive, symmetric, and transitive properties are true. Angles supplementary to the same angle or to congruent angles are congruent. And angles complementary to the same angle or congruent angles are congruent. And that's proved on page 109 in your book if you'd like to see it. We will prove theorem 2.6 in exercise 6. In the figure, angle 1 and angle 4 form a linear pair, and the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Prove that angle 3 and angle 4 are congruent. Okay, we are given that angle 1 and angle 4 form a linear pair, and measure of angle 3 and angle 1 adds up to 180. They want us to prove that the measure of angle 3 and angle 4 are congruent. We're going to start by stating our given. Oh, bummer, the PowerPoint left off half the given, so I needed to add on there angle 1 and angle 4 form a linear pair. And then from linear pair, we know that angle 1 and angle 4 are supplementary because linear pairs are supplementary. Measure of angle 1 plus measure of angle 4 adds up to 180 because supplementary angles add up to 180. If I use the subtraction property on both this first equation and the one we just had and subtract measure of angle 1 from both sides, measure of angle 4 from both sides, I get measure of angle 4 equals 180 minus measure of angle 1, as does measure of angle 3, which is handy. So now I can state that measure of angle 4 equals the measure of angle 3 by substitution. And to be really perfect, we should write it the exact same way they had it in the to prove here. So, ooh, that's actually not even the same. Nice. They wrote angle 4 is congruent to angle 3. Haha, the order is different. Definition of congruent angles. We did a quick informal proof of the vertical angles theorem in the beginning of the video. If two angles are vertical angles, then they are congruent, and it's abbreviated VERT. Angles are congruent. If angle 1 and angle 2 are vertical angles, the measure of angle 1 equals d minus 32, and the measure of angle 2 equals 175 minus 2d. Find the measure of angle 1 and angle 2. Well, we know vertical angles are congruent, so I set that up. We can add 2d to both sides of the equation. So now we have 3d minus 32 equals 175. We can add 32 to both sides of the equation. So 3d equals 207. Divide by 3. And d equals 69. Are we done? No, they said find the measure of angle 1 and angle 2, so we need to substitute back in. So into the angle 1 equation, looks like the easiest one, we could do 69 minus 32, which is going to be 37, which should be the same for both angles. So the measure of angle 1 and angle 2 are both 37 degrees. Perpendicular lines intersect to form 4 right angles. Theorem 210, all right angles are congruent. 211, perpendicular lines form congruent adjacent angles. Theorem 211, or 212, if two angles are congruent and supplementary, then each angle is a right angle. And theorem 213, if two congruent angles form a linear pair, they are right angles. They have thrown so many theorems at you so rapidly that if you take careful notes, I will allow you to use them on quizzes and tests. Write them down. The properties of equality and congruence can be applied to angle relationships, and there are a lot of them.